Now let's try to understand how this matrix factorization concept is useful in the on features engineering. Okay, how this concept is useful. Let's see. So suppose let build the recommender system that a matrix we have built A. This is the A matrix and the dimension of this matrix is n cross m. N cross m. This n is responsible for number of users. Here n is equals to the number of users and is m is responsible for the number of items. Number of items in our data sets. And the h row here h row u1, u2, somehow ui and un. This is the users. This is the users and this is for the items I1, I2. This is for ij, item j, and this is for im, item m, item m. Okay, n is the number of item users, sorry, and m is the number of items. Okay, that's the thing we have seen. And the common element here, this one the aij. That's mean the some rating or some product review, some things like. So this is the somehow aij is rating or somehow like. So now the questions that we have to factorize this matrix. How will factorize? Just in previous lecture we have seen this matrix is factorized like that. B into C transpose. Okay, we will factorize, just make some spaces. B into C transpose. Here we have to factor this matrix like that. Okay, so the dimension of the A is here. Dimension of A is here n cross m. And dimension of the B will be n cross D. Similarly, for the dimension of the C here, the C transpose, I'm talking about the dimension of the C transpose will be D cross N. So for these reasons, the dimension of the B, so the dimension of the B will be N cross D, and the dimension of the C will be M cross, sorry for that, it's M cross D. Okay, and this vector, this D is the relations of the D must be greater than 0. D must be greater than 0 and D is less than equals to minimum of M and N. We have seen this thing already. These are the relations of the D to the M. Now the question is, what is the features vector? Means we have to build the features for corresponding age user and corresponding age items. That's the job here. We have to we have to do by using this simple matrix factorizations. We have to do. So how we will doing this job? So just compare this matrix. So the job that we have to do, we have to calculate the features vector for users. Suppose let user, we have to calculate the features vector, the task. The task is to build the features vector for each user. And this dimension of this vector is 1 to up to D. Okay, this dimension. Okay, and this I will be running for 1 to n, where n is equals to the number of users, and Vj, here the Vj will be the features. Sorry for that. Ij. Once I'm talking about Ij, this Ij. The Ij will be the features vector for each item. Okay, its dimension also be D. is somewhere D. This is the J will be from how much item we have? We have the M items, so J will be 1, 2 up to M. Okay, so where M is the number of items. M is the number of items. That's the main job, that we have to find the A's UI and HIJ. That's the job that we have to do. So let's see how we'll doing this. So the B that we have to find, by simply using this matrix factorization. That B, the shape of the B is look like this. The dimension of B is what? The dimension of the B is n cross D. So just see that B matrix first, very carefully. So dimension of the B is n cross D. Okay. So for that, so this n is the number of users. This is the number of users. And D is the dimension of the features. This is the dimension of each feature. Now dimension of the each feature vectors. Okay. So here actually we have n rows and D columns. That means that, so n row means this n is responsible for number of users. So the row here for the matrix B, row will be responsible for is user, UI, UN. Okay, this row will be now responsible for is user, and here it will be 1, 2, 3 up to this value will be D. This row. Now this matrix row, this row is called the features vector of the user UI. This row matrix is called the features vector of the, means I'm talking about the BUI. That means the ith row of B. Okay, that's actually the UI is the features vector of the user UI. Okay, is the features vector of the user UI. Okay, that's the thing. So here UI is a d-dimensional vector. UI is a d-dimensional vector. So UI must be lie on RD. UI must be lie on the RD. Okay. So C. Now let's see what is the importance of C here. Here the dimension of the C is M cross D. What is the importance of the C? Let's see. So this is the, I think it's better if I taking this symbol. Okay. So here the size of the C is what? M cross D. M cross D. M is what? M is responsible for number of items. This N is for number of users. Here M is for number of items. And the D is that D is the dimension of the H features vector. This is the simple dimension. Dimension. Okay. If I'm doing some mistake, please correct it. Okay. These are the dimension. So since here M is the number of rows for this matrix C, so the number of items will be here like that. I1, I2, I3, like item G. So sometimes it will be item M. Okay, and it is the in column it will be the dimension of the each item, features vector dimension. So here the thing that the vector for the item J, this vector This vector is called the features vector of the age item corresponding to age item. This is the features vector for corresponding to age users. This is the features vector corresponding to the age item. This jth row, this jth row of C, jth row of C means this is the ij. I'm talking about ij. Which is the features vector, is the features vector of the item or product, or any product. Features vector item or product ij. Okay, these are the product vector, and obviously it's a d-dimensional vector. You see it, it's obviously d-dimensional vector, and it's also rely on the rd. Okay, I think you got the idea how to find this features vector for each item, for each item and each, for each items and each users by simply using this matrix factorization technique. I think you got the idea. This is the simple technique that we have to follow, that we have to maintain. So the d-dimensional representations you arrived by using the features matrix factorizations, the d-dimensional features transformation. Actually, just see it. But d is the what? Just see the d is the this one. So as our requirement, how much d, how much features, how much dimension we have to choose, we can easily choose by simple following this rule. So we can easily, as our requirement, as our requirement, we can choose d, we can choose d by simple using this rule, by using this, by using this formula we can easily choose as our requirement by simple using. The d must be less than equals to m and n. That's the first condition, and obviously it's greater unless it is unnecessary in our calculations. Okay, this is a trivial thing. This is trivial. Okay, so the things that we got here, the d-dimensional representation, the d-dimensional representation that we arrived, by using the matrix factorization technique. So here ui and the that we arrive means after finding this features vector, that means what? This is the vectors ui and uaj as the represent features vector for the each items. If suppose let the thing is by simple after arriving this, if we got if item user ui and user uj are the very similar ratings in their products. Okay, if for a product, if they got, if we give the very similar kind of ratings for each product, means the choices of these two users are likely similar. Means the thing is if ui and user uj ui and uj are very similar, in their ratings of the product, of the items or product, of the products, or you can call, if their choice are like similar, if their choice is likely similar, is likely similar type. If they both are the same kind, choosing same kind of product, okay, in if these things happen, then we can conclude that, then we can easily conclude that the distance of these two vectors at the end of that, these are the big vectors for edge users, okay, these are the features vector for edge users. So the distance of the features vector for these users ui and uj must be very small number, must be a small value, must be a small value. This is the thing. If these two users are the very similar, then this value will be must be small value. That's the important. So from these feature vectors, it will help us to find the which users are the similar type of mentality. That will help us to find. Okay, the same things also applicable for items. If the two items are very similar, then the distance vector will be must be the distance value will be small value. So if the item I and item j are very similar, based on the ratings of the user, very similar based on the users. Why these things? Actually, just see the matrix, A matrix. Actually, we have computed this B and C, means the features vector for the items and the users by simply using this data, by simply using the rating of the H product, by simple this data Aij. These are the Aij. Aij means what? These are the ratings of UI user I to the item ij. Okay, by aij this is a simple thing. Okay, we will actually use this aij to compute this matrix, factorized matrix. So because of this, because this the features vector, these are because these features vector for ii and ij are will be very similar based on the rating of the user. So since we have used this rating for the edge users, because of these reasons, this value, if this value are the similar, so then their distance must be. So then their distance, it may be Euclidean distance, it may be cosine distance, anything. So in general, typically we will use for this vector the Euclidean distance. The distance between A and ij must be a very small number. A very small number. If this happen, this got this thing. Okay, we got this thing. If these things happen, and S, UI, and UJ must be a D-dimensional. So we will choose this D according to our requirement. What will be the thing? Okay. So these are the simple thing that we will use to find the feature vector. By simple, we use this matrix factorization concept. I think you will understand this concept from these discussions. So just conclude these things. If you make some conclusions. So the matrix factorizations that we will used for the features engineering, we will use this matrix factorization for features engineering. Now in future video also we will see how this matrix factorization concept is also useful for word to vector, for word to vector. Word is simple. What word is simple? A text data. So we have not used this text to our computation. Somehow we have to convert this word vector to a vector format. Okay, we will see how this matrix factorizations concept is useful to convert any word vector, means any text data, to a numerical data. We'll see. So it is the similar type of things. We will see these things. Word to vector, and also we will see by simply using this matrix factorizations concept, we'll see how to convert a feature, how to find a eigenfaces, how to find this eigenfaces, we will see. So these eigenfaces are mainly used in the computer vision. This is a very old technique. So this is to features engineering for find the features for face images mainly. These eigenfaces, that's the features that we have to use for finding the means faces for face images. Okay. So these are the techniques for the feature. These are the features engineering technique for face images. For face image. Okay, it's a very old technique, in very early technique. In those days, the huge amount of computations are not available. In such cases, the data scientists are used this kind of technique to find the human faces or somehow faces. Okay, these are the technique. We will see this thing. So in future video, in this siege, in future videos. Okay, so I think today's the concept of this feature engineering, how these things are applicable, the motto of these lectures is clear all of you. Okay, so I think if you have any problem, please recap these things. I think these things are also related to the previous video. So by simply using the gradient descent optimizations algorithms, we will found this B and C transpose. The same things also applicable here. Okay, so I think you got the idea how to use these matrix factorization techniques to find these features vector for any product or any users. Okay, so we'll see in next video. We'll see how this matrix factorizations concept will be useful for clustering technique. We'll see these things in next video.